Look closely at your screen. Every single thing you see is made of tiny pixels. If you zoom in close enough, the image breaks down into blocks. But what if I told you the universe itself is exactly the same? What if reality has a resolution limit, a point where you cannot zoom in any further because space itself stops existing? This isn't a simulation theory, it's hard science. And at the very bottom of reality lies a number so incredibly small, it makes a single atom look like an entire galaxy. We call it the Planck length. And once you cross this boundary, everything we know about space, time, and gravity completely shatters. To understand how, we first have to go on a journey deep inside the void. To comprehend just how small this limit is, let's take a trip downward. Think of a single grain of sand on a beach. Now zoom in to a single atom inside that grain. An atom is small, but we can go much deeper. Inside the atom is a proton. Zoom in again, and we find quarks, the fundamental building blocks of matter. But we are still nowhere near the bottom. To reach the Planck length, you would have to zoom in 100 billion times smaller than a proton. If a single proton were the size of our entire observable universe, the Planck length would be about the size of a regular trip to the grocery store. It is just 1.6 times 10 to the negative 35th meters. And at this scale, the very fabric of our universe starts to tear apart. This is where science gets terrifying. For over a century, physics has been ruled by two main pillars: Einstein's general relativity, which explains the smooth, predictable curves of space and gravity, and quantum mechanics, the wild, chaotic world of subatomic particles. Usually, these two theories mind their own business. One rules the big, and the other rules the small. But at the Planck scale, they are forced to meet in a head-on collision. And when they do, the math breaks. Literally. Our equations start spitting out infinity as an answer, which in physics means we have absolutely no idea what is actually happening. Because at this scale, space is no longer smooth. It is a violent, boiling mess. If you could look at space at the Planck scale, you wouldn't see empty darkness. You would see what physicists call quantum foam. Here, space and time are no longer stable. They are bubbling, warping, and tearing. Microscopic black holes and wormholes are constantly popping into existence and vanishing in less than a trillionth of a second. Even the concept of before and after loses all meaning, because time itself becomes fuzzy and disjointed. You cannot measure anything smaller than this, because the act of trying to observe it would require so much energy it would instantly create a black hole and swallow your experiment. Nature has literally locked the door and hidden the key. But why does this tiny, hidden limit actually control the largest things in our cosmos? This isn't just some abstract math puzzle. Understanding the Planck scale is the only way to unlock the two greatest mysteries of the cosmos: the center of a black hole and the very beginning of the universe. According to current science, if you fall into a black hole, you eventually hit a point of infinite density, called a singularity. And the Big Bang allegedly started from an infinitely small point. But infinity doesn't exist in the real world. The truth is, both the Big Bang and black holes are squeezed down to the Planck scale. If we can figure out what happens at this ultimate limit, we can finally see what happened at the exact moment of creation and what lies inside a black hole. But to do that, we need a whole new... To solve this, scientists are working on radical new ideas. One is string theory, which suggests that everything is made of tiny vibrating strings of energy operating at the Planck scale. Another is loop quantum gravity, which says space is made of tiny woven loops like the threads of a cosmic sweater. Both of these theories are trying to do the same thing: find the theory of everything, a single equation that connects the smallest pixel of reality to the vast emptiness of space. Until we find it, the Planck length remains the ultimate border of human knowledge, a quiet reminder that no matter how far we look into the stars, the deepest mysteries of the universe are hidden right under our noses in the invisible pixels of reality.